Okay, so let's do probability topic. Remember, with probability of a single event, it's the number of successes over the total outcome. Total outcomes. Total number of outcomes. Okay, if a letter from the word mathematician is chosen at random, what is the probability it's a vowel? So any letter in the word mathematician, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 letters in the word mathematicians. Those are all the possible letters that could be chosen, all 13. But there are only 1, 2, 3, 4, 5, 6 vowels to choose from. So if you got one of those 6, that would be successful in getting a vowel. So 6 out of 13. As a decimal, it'd be 0.46. And then as a percent, if you times it by 100, that'd be 46%. A number from 1 through 30 is chosen at random. What is the probability that the number is a 2-digit number and prime? Okay, so there's 30 numbers from 1 to 30. It needs to be 2 digits and prime. So 2 digits starts at 10. So this is when I'm going to pull up my cheat sheet and look at my prime numbers that are 2 digits. So here's my cheat sheet. We're doing prime numbers that are 2 digits to 30. So starting at 11, going all the way to 30. It's those. So we have 1, 2, 3, 4, 5, 6. 6 2-digit numbers that are also prime. When you simplify that fraction, you get 1 over 5. As a decimal, that's 20 cents. And if you times that by 100, you get 20%. If a standard card is selected at random, find the probability from a standard deck. What is the probability that is a face card or an 8? So the probability it's a face card or an 8. There are 52 cards. Face card or an 8. So back to my cheat sheet, going look at my cards. Here are my face cards. Hey, we've done this question. And then here are my 8s. So since it's or, it's any of those. So 3, 6, 9, 12, 13, 14, 15, 16. 16 face cards or 8s. And then that reduces. 4 over 13 as a decimal rounded, that would be 0.31, and times that by 100, that'd be 31%. It's telling me to do all 3 where I want it. If a card is selected at random from a standard deck of cards, what is the probability that is an ace or red? So there are 52 cards we're choosing from. There are 4 aces and there are 26 red cards, 13 diamonds, 13. So we have 13 diamonds, 13 hearts, and 4 aces, but 2 of them are red, so we need to subtract. So these are my red cards, and then add the 2 black aces, is how I'll say that. 13, 13, that's 26, 27, 28. Which is 7 out of 13. Or if you make it into a decimal, 0.54 by rounding, or 54%. Okay, ace or a red card, just to show you. Ace or red card. So these are all my red cards, 13 in each suit. So 13 here, and then these are my aces. So that's 26, that's where the 26 came from, plus these 2 aces. 26, 27, 28. Hope that helps. All right, of 125 students enrolled in dance, 96 take ballet, 50 take jazz, and those who take ballet, 28 also play jazz. So we need 4 numbers. 1, 2, 3, 4. Always start in the middle. How many take both? 28. Ballet, This whole circle has to add up to ballet. So 96 minus 28, because we already have 28 in that circle. 96 minus 28 is 68. So 68 goes just ballet. And then we're going to do the same thing for jazz. The whole circle has to add up to 50. And we already know the middle 28 take both. So that leaves us with 22 who just take jazz. And then we still need this whole box to add up to every student in the dance studio. So with the whole box, all four numbers need to add up to 125. And right now we're adding up to 1, 8, 16, 17, 18, 8, 1, 6, 118. So 225 minus 118. We have 7 still students unaccounted for. So these 7 do not take ballet or jazz dance. They take mambo. Who knows what they take? They do something else. All right, so there's your Venn diagram. Now, if a dance student is chosen at random, give the answer in the simplest fraction. So ballet or jazz, that's all 3 of these together, ballet or jazz. So 68 plus 28 plus 22 over all of them, 125 would be 118 out of 125. Or is the inclusive, these 3. These 68 take ballet, these 28 take ballet and jazz, and these 22 all just take jazz. Ballet but not jazz, that's the 68 we found. So 68 over 125. Neither ballet nor jazz, that's the 7 on the outside. 7 out of 125. Remember, probability can never be more than 1, so these always have to be fractions or decimals, but they can't be over 1 even if you simplify it. Okay. Okay. A shuttle bus arrives at the hotel every 40 minutes to take a guest into town. If a guest walks out the door at random, find the probability of each wait time. So if you walk out the door, first off, out of how many numbers? What is our bottom number? If you walk out the door and the bus just arrives, you have a 0-minute wait time. So that's one of my numbers. Then 1, 2, 3, 4, 5, 6, all the way. This is how long you're waiting. Now, if you walk out at 40, the bus is going to be there again. So we're back to 0. So there are 40 different minute wait times, but 1 is just 0. So we're not including 40 because if you walk out every 40 minutes, you have a 0 wait time. You're walking straight to the bus. So how many are at least 15? So 15 or more. That's this many. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 minutes out of 40. Or 5 out of 8. Okay, and then the same again, it's still only out of 40 because it's not 41, because if you're waiting 40 minutes, then it's going to be 0 wait time. You're going straight to the bus. These are questions we didn't have to do. I'm just trying to get rid of that circle. Yay, okay. No more than 10 minutes. That means 10 minutes or more. Or less, I apologize. So 0 is less. No more than 10 minutes. So 10 minutes or less. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 out of 40. And that doesn't reduce. Okay, and then compound events is 2 things happening at once. So you have the probability of one event, and then if they're independent, they don't affect each other, then you'll do times that by the probability of the other event. If they're dependent, that's going to change, but you'll still find the probability of A, and then you'll multiply that by the probability of B given B after A has occurred. Since A happening will affect B because it is dependent on each other. So each spinner is spun once, find the probability of each event. These spinners have nothing to do with each other, so these are independent. So once we find the probability of blue, well, there's 1, 2, 3, 4, 5, 6, 7, 8. 8 here. In blue, there's 1, 2, 3. So 3 out of 8. Times the probability that this spinner is even. Well, there's 10, 1 through 10, 10 numbers, and the even numbers are half of them, so 5. And then multiply across the top, across the bottom. So it's 15 out of 80, and then in simplest fraction form, 3 out of 16. Okay, the first spinner, not red. So there's 8, and then there's 1 red, so that means 7 of them are not red. Times the probability that's less than 7. There's 10 numbers. Less than 7 does not include 7, so these 6. Oh my goodness, 7 times 6 is 42 over 80. And then if you reduce that, you'll get 21 over 40. Probability it's green, there's 8 options. The green is, there's 2 of them. Times a number at least 3, so 3 or more, at least 3. These, not these 2, that means there's 8 left. So it's 16 over 80, which is 2 over 10, 16 go into both of those numbers, 1 over 5. Okay. A month of the year and the numbers from 1 through 40 is chosen at random. What is probably that the month begins with the letter A and that the number is a perfect square. These have nothing to do with each other. So we need to know the probability. You get an A month, and then we're going to do times the probability we get a perfect square So the probability of an A month, there are 2, April and August, times the probability of a perfect square between 1 through 40, so that's 40 numbers. And if you go to your cheat sheet, which is somewhere, our perfect squares up to 40, well, those are prime numbers, perfect squares are these. So 1, 2, 3, 4, 5, 6 of them. 6 out of 40. So that's 12 out of 480, which reduces to 1 over 40. Okay. A coin is tossed 4 times with probability of getting tails each time. Well, these are not, flipping a coin does not depend on the other one. So we need to know the probability of getting a tail 4 different times. The probability of getting a tail, the probability of getting a tail, the probability of getting a tail. 4 different flips. Well, every coin is 2-sided, and a tail, there's 1 of them. So 1/2, 4 different times for each flip of the coin, or toss of the coin. So it'd be 1 over 2, 4, 8, 16. 1 over 16. A jar contains 15 quarters, 9 dimes, 10 nickels, and 6 pennies. So this jar has 15 plus 9 plus 16, 40 coins in it. Total. Okay. A coin is selected at random, not replaced. So if it's not replaced, this is dependent. So this is when we're saying the probability of a dime times the probability of a nickel after the dime. This is what independent means. Okay, so the probability of getting a dime is 9 out of 40. Fine. So now I have a dime in my hand, and I'm not putting it back, and I'm going back in for a nickel. Well, there's still 10 nickels in the jar, but now there's only 39 coins in the jar. And if you multiply and simplify those, you will get 3 over 52. Hey, just like cards. Okay, so these are dependent compound in probabilities. So the probability of a quarter, there's 15 quarters out of all 40, times, I'm not putting that quarter back, so now I only have 39 quarters, and we still have 6 pennies. Put them in the calculator. I should show you at least one in a calculator. Alpha y equals enter. You can put them in as fractions. 15 times 40. Your calculator knows how to do it. Cross top, cross the bottom if you want to do it on your own. 6 over 39. And 3 over 52. Hey, same thing again. It's a coincidence. Don't think it's always going to happen. All right, they're both dimes. So 9 over 40 times 8. Oh, I didn't explain. So we had 40, I got a dime, and I'm going back for another dime. The probability of a dime given a dime is chosen. So I already have a dime, so now the top number is changing too because we're doing it 2 times in a row. And the bottom number is changing. So the probability I chose a dime the first time is 9 out of 40. Now I have a dime in my hand. Now there's only 8 left in the jar, and now there's only 39 in the jar total. And that would give you 31 out of 52. So just be careful with dependent if both the numerator and denominator are changing or just the denominator. Last 2, and I'll end this video and start the last one. A card is chosen from a standard deck, not replaced. That means dependent. Then another one is chosen. What is the probability that both cards are a spade? So a probability, we're looking, if this was written out, probability of a spade, then another spade. So there's 52 cards. Every suit has 13. I am not replacing it. I have a spade in my hand. I'm not replacing it. So now I only have 51 cards to choose from. And since the spade's in my hand, there's only 12 of them now, which is 1 out of 17 if you put that in the calculator. A letter from the word bookkeeper is chosen at random, not replaced, and then another letter is chosen. So bookkeeper has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. What is the probability of choosing a K? There are 2 Ks. So 2 out of, and then an E. So I'm not replacing it. I have a K in my hand. Now there's only 9 letters in the word bookkeeper. And out of those 9 letters, 1, 2, 3 of them are E's. 2 times 3 is 6 over 90. 3 goes in both of those, so 2 out of 30. Shoot, 2 goes in both of those. I said 2, I meant 3. So 60 must go in 90. Because then that'd be 1 out of 15. Just put in the calculator. All right. One more video.